You know that feeling when you're staring at a page of dense university lecture notes and your brain just starts to fog over? Yeah, we've all been there. Well, today we're going to tackle that head on. We're breaking down one of the most important but kind of confusing processes that keeps you safe online every day, the TLS handshake. By the time we're done here, those notes are going to make a whole lot more sense.
Okay, so here's our game plan. First, we'll get to the heart of why we even need this thing by talking about the internet's trust problem. Then we'll introduce the solution, the digital handshake. After that, we'll compare the old way, TLS 1.2, with the new, much faster TLS 1.3. And finally, we'll wrap it all up with why this matters, not just for the internet, but, for that exam you've probably got coming up.
So, first things first, you have to remember that the internet wasn't originally built for things like online banking or shopping. It was built for openness, not really for trust. And that simple fact creates this huge fundamental challenge for pretty much everything we do online today.
I mean, really, think about it for a second. When you type in a website, your computer just sends a request out into the void. How does it really know that the server that responds is actually your bank and not some imposter waiting to grab your password? And how can you be sure that no one is listening in on that conversation?
Your lecture notes use a great analogy for this. It's like a digital blind date. Before you start sharing any personal information, you've got to solve two massive problems. Number one, prove you are who you say you are. And number two, make sure you can talk in private without anyone eavesdropping. That's the core problem that TLS was invented to solve. And that brings us to the solution. It's the super formal, highly structured introduction called the TLS Handshake. Think of it as the set of rules that turns that risky digital blind date into a secure, verified, and private meeting.
Now, before we go any deeper, let's clear up a key term from your notes: protocol. Don't let the word intimidate you. All a protocol is a rulebook. That's it. It's like a shared language that lets two completely different computers, maybe made by different companies, speak to each other and understand each other perfectly.
So, the handshake protocol is just a special rulebook for one job, starting a conversation securely. The whole point is to get both sides perfectly in sync. Your notes might call this a stateful protocol, which sounds complicated, but it just means that once the handshake is done, both your computer and the server remember the rules they agreed on for the whole conversation. They don't have to renegotiate every single time you click something.
When you really boil it down, this whole complex process has four main steps. First, your browser, the client, says hello. Second, the website server says hello back. Third, and this is the super important part, your client checks the server's ID to make sure it's legit. And finally, once they both agree, they confirm the secure connection, and you're good to go.
All right, let's get into the nitty-gritty, and we'll start with the older version of this protocol, TLS 1.2. I like to call it the chattier version, and you'll see why in a second. Understanding how this one worked makes the improvements in the new one really pop.
Okay, this diagram is pretty much the heart of the whole lecture. It might look a little intense, but we're going to walk through it. Let's just focus our eyes on the left side for now, the one labeled TLS 1.2. This shows the flow of messages between your computer, the client, and the website server.
See all those arrows going back and forth? That's what I mean by chatty. The client says hello. The server says hello back. Then another message, and another one. It's a whole conversation just to agree on things like which encryption to use and to verify their identities. All of this has to happen before a single piece of the actual website you want to see can be sent securely.
That inefficiency, all that extra chatter, is exactly what the modern standard TLS 1.3 was designed to eliminate. So let's check it out and see how it makes this whole greeting smarter, faster, and even more secure.
Now, shift your focus to the right side of that diagram. See how much cleaner it is? With TLS 1.3, the client is a lot smarter. In its very first hello message, it also sends something called a key share. It's basically anticipating what the server is going to need. It's like saying, hi, let's talk, and I'm guessing we'll need to create a secret key, so here's my half of the recipe to get us started. This one move dramatically cuts down the back and forth.
And this gets us to a really crucial concept, especially for your exam: round-trip time, or RTT. All this means is the time it takes to send a message and get a reply. Each back-and-forth conversation in that diagram takes time. So the main goal in upgrading TLS was to reduce the number of these round trips. Fewer round trips means less waiting and a much faster feeling website.
So here's the bottom line. For the old TLS 1.2, you needed 2 full round trips, 2 complete back and forth exchanges just to get things set up. We're talking about milliseconds here.
But when you're loading a complex web page, those milliseconds add up and make everything feel just a little bit slower.
And then TLS 1.3 comes along and just slashes that in half. By being smarter and sending more information up front, it gets the entire handshake done in just one round trip. That is a massive improvement in performance, and it's a huge part of why secure connections today feel almost instantaneous.
So let's bring this all home. Why should you care about any of this? Well, beyond just making sense of those lecture notes, this process is working for you constantly, every single day, and knowing the basics is key.
Okay, if you're making study notes, these are the absolute must-know points. 1. The whole point of the handshake is to create a secure session. 2. It proves who the server is by using digital certificates. Think of it like a website's unforgeable driver's license. 3. TLS 1.3 is better than 1.2. It's faster and more secure. And 4. The big one, the most important improvement is that it cut the handshake down from 2 round trips to just 1. If you remember one thing, make it that.
The real-world takeaway is super simple. Every time you see that little padlock icon in your browser's address bar, this entire handshake process just happened. The shift to TLS 1.3 means that secure connection was made faster and with even stronger security, making your whole online experience better.
And that leaves us with a final thought to chew on. We've just seen how much incredible engineering goes into something as simple as a digital hello. It kind of makes you wonder, right? What other invisible, genius protocols are working in the background right now just to make our connected world possible?